Running, yeah. All right. We used to do the drill where you'd run. Then a guy's got to. It's like, all right, best free throw player goes to the line. He's got to make both of them, or you guys are gonna run again. And we were just praying that he would make it.
Yeah.
So,
Yeah, I hate that, man.
all right. Well, let's talk a little bit about exponential functions. Functions. So something like y equals 2 to the x. So this is different than maybe what you've seen before. It's a number to a variable. Have you seen that before? Maybe in a previous class?
Uh, maybe. I don't
Okay.
know.
Any idea what the graph of this looks like?
Uh, y equals 2x.
2 to the x, 2 to the
Oh,
power
2
of
to
x.
the x. Okay. I have no idea. I don't even know.
All right, so it looks like this. It goes up and to the right, goes up forever, goes to the left forever. Have you seen that before?
Yeah.
Good. All right, so if we were to make a table for the parent function, can you tell me what these first three x values would be? It's 2 to the 1, 2 to the 2,
Yeah.
and 2 to the 3. Do you remember what exponents?
Well, I think it would be 2, 4, and 8.
You got it. Now, do you remember what anything to the power of 0 is?
It's either 0 or 1.
It is 1. Now, the hard one here is 2 to the minus 1. So anything to a negative exponent becomes 1 over that thing to a positive exponent. So 2 to the minus 1 becomes 1 over 2 to the 1.
Okay.
So that becomes 1/2. So if we were to go back to that graph that I showed you, you can see there 0, 1, -1, 1/2, 1, 2, 2, 4, and so on.
Yeah.
Okay, so that's kind of one direction we could go with this is doing some transformations of exponential functions. Okay. We could
Yeah.
also do what are called some solving of them, of the exponential functions. And so I'll give you an example of that now. So let's say you had 3 to the x squared equals 3 to the 1. You will be asked at some point to try and solve this type of equation.
Okay.
So have you seen anything like this before?
No, I don't think so.
Okay. So when the bases are the same, and when I say base, the base is the thing on the bottom, exponent is up top. You set the exponents equal. So in this case, the exponent isn't necessarily an exponent, it's a function, but you would set x squared equal to 1. Do you remember how to solve something like that?
Excuse me, sorry.
Okay.
Ugh. Uh, x squared equals 1.
Yeah.
Well, it would just be 1, right?
Is that the only solution?
-1 as well, though.
Yeah, there's two solutions. Okay. So x could equal 1 or -1. Very good. Okay, so let me put another problem in front of you. Do you have a notebook out, some pencil and paper?
Yeah, I do.
Great. All right. So I'd like you to try solving this one. It's just like the last one in the sense that the bases are the same. bases are the same. So you set the exponents equal. And I'm going to just step away for 30 seconds or less. Be right back. Okay, so when I say setting the exponents equal, 3 minus 2x equals minus x.
Yeah.
So do you remember how to solve an equation like this?
Um, let's see. You can put the x's together.
So you can move from the smaller to the larger because there's variables on both sides. So which is smaller, minus 2x or minus x?
Minus 2x.
So you undo that by adding 2x to both sides.
Okay, so it's 3, right? Oh, wait,
Uh,
that
Give
would
me your
not be.
final answer.
Well, 3 equals 1x, which is the same thing as 3
Good.
equals x.
Okay, so these do not always work out like perfectly, like nicely. They're not always like integers, but sometimes they are. Let me give you a problem to try here, please.
Okay. Mm, okay, I got 2 equals a.
A equals 2. Good. Okay. Now this next one's going to be slightly more complicated. Uh, Not a ton, but slightly more complicated. All right, so take a look at that, please.
All right. Mm-mm. Hmm. I got p equals -1/4.
You are correct. Good. All right. Now we can move to a new style of problem. Okay. So let's say it's 3 to the x minus 4 power equals 81. Okay. So in this problem, do you see that the bases are not the same?
Yeah.
So strategy number one is to go from the larger base to the smaller base. So the idea is, can you make 81 into 3 to some power? 3 to some power. Okay. Um, any idea on that?
Um. Uh. Yeah. Yeah, yeah, whatever. Let me think. Hold on.
So in the chat, I put a handy reference there from my website. It's the exponents
Is
that
it
I
4?
think
I'm gonna say 4.
students ought to know. Yeah, it is 4. And um, so now you can set the exponents equal and solve the equation. Would you do that for us, please?
Oh, oh, there you go. The link works. Okay. Yeah. Let me do. So x equals 8.
Yes, x equals 8. Very good. Okay, so here's one for you to try. Same idea, just different numbers. Could you give that a try, please?
Yeah. Oh, okay. Oh, there we go. Okay. Alright. Okay. Okay, so -2 equals x.
Oops, sorry, I scrolled up on that. You said -2 equals x? Yes. Very good. Okay. Now, another type of problem that you will see is where, let me snip this in here. Your goal is still to make the bases the same, but this time 8 is really 2 to the power of 3, all to the x minus 1 power. Is that clear that 2 cubed is 8?
Yeah.
Okay. Now, do you remember the rule when you have a base to an exponent to an exponent, something like x to the n to the power of m?
Um. No.
So you multiply the exponents. So in this case, you're going to take that 3 and you're going to multiply it by x minus 1. So it's 2, 3, x minus 1. And so now you can set the exponents equal. And this is definitely a problem you'd want to write down if you're taking
Yeah.
notes.
Okay.
Um,
Okay. Got it.
could you solve that equation for us, please?
Yeah. Let's see. Okay, so x equals 5/2, or 5 divided by 2.
Yes. Perfect. Okay. So again, just if we kind of recap the problem here, your strategy we're working on right now is where you make the larger base into the smaller base. And if it's to an exponent and you've got an exponent, you have to then multiply them together, and then you set them equal and solve.
Okay.
So let's have you try one here on your own like that. I'm going to just step away again for 30 seconds. Be right back with you. Okay, I am back.
Okay.
Let me know if
Uh,
you have any questions on this one or how to set it up. Or
I think I know how to do it. Would you multiply 2 by 5x minus 1 because of the. Oh, wait, no, no, no. It would be
take the
2
larger
by.
base and turn it into the smaller base. Like, how do you turn a 144 into 12 to some power?
Yeah, 12 to the second power.
Okay.
So it would be 2 times 2x plus 1 then. Okay,
Yes.
yeah.
See if you
Okay.
can solve it from there, please.
All right. 3 equals x.
X equals 3. Let's see here. 7. Yes, that is correct. Very good. Okay, let me have you try one more before we move on to the more difficult type. Go ahead and try solving this one, please.
Okay. Okay, I got a equals -7 over 5.
Like that?
Yeah.
Okay, that is correct. All right, so the next style of problem we're going to work on here, and we need just a little bit of a reminder here. 1/2 is really 2 to the power of -1. Okay, and that's that whole negative exponent thing that if you have a negative exponent, you can bring it to the bottom and make it positive. But if you go back up, it becomes negative. So could you tell me what 1/3 would be using negative exponents?
um, 3 to the. Uh, yeah, negative. Okay.
3 to the
Yeah.
-1.
Okay.
About 1/5. What would that be?
5 to the -1.
Good. Okay. Now this is where it gets a little bit more complicated here. Let's say it's 1/4. There's a couple of ways to write it. What's the first way based on what we're doing the last three problems there? Three
4 to
numbers.
the -1.
Yes, but it could also be 1 over 2 squared. Do you agree that 2 squared gets you back to 4? So this would be 2 to the -2 power.
Okay.
Okay, so let's look at like 1/9. What's the two ways you could write 1/9?
9 to the -1.
Oh, that's really bad. Okay, not you, me. All right, and what's another way?
Um, well, are you trying to say that that's 3 squared, basically?
Okay, good,
So 3 to the negative, or -2. Yeah.
good, good. How about let's try another one here. About 1 over 16.
16 to the negative 1,
Okay.
and 4 to, well, 4 to the 4th.
4 to the 4 is 4 times 4 times 4 times 4, which is
Oh,
256.
yeah, that's a little bit too much. How about 4 squared?
4 squared does work. So what would that be as a negative exponent?
4 to the negative 2.
All right. And then could you write it as 2 to some power to get back to 16?
Yes. Mm,
What would that
yes,
be?
2 to the 4th, right?
So this would be 2 to what power as a negative exponent?
The negative 4.
Good. Okay. Now, there's a couple of other ways you could proceed here. Just so you can sort of get the full perspective. Because it really is up to you how you identify this. Once you get to the right here, you could say, oh, 16 is really 4 squared. 4 squared to the negative 1 power, you multiply the exponents, and that gives you 4 to the negative 2, which is exactly what we had here.
Okay.
You could also say, well, 1 over 16, 16 to the minus 1, it's really 2 to the 4th power to the minus 1, which becomes 2 to the minus 4 power because you multiply the exponents.
Okay.
Okay, so now in the problems we're going to do now, we're going to convert the fraction base to the whole number. Okay, so here's an example. 1/3 to the power of, or let's just do that, equals 3 to the x minus 1. How can you rewrite 1/3 as a whole number? We're going to take the fraction to a whole number. How did we rewrite this? It's 1/3.
Um, well, I don't
Let's go
know.
back
3
and
to the
look.
negative 1.
Yes, yes,
Okay. Yeah.
yeah. You'll find I often lead into what we're going to do. Now what? Now what can we do?
Negative 1, and then you solve it. So negative 1 equals x minus 1.
Okay,
So it's just 0 equals x.
x equals 0. Good. Okay, now let's try this one here. 5 to the 2 plus 3x equals 1/5. So for the fraction, you're going to convert the fraction to 5 to some power like we were talking about.
Okay. I get it. So we 5 to the negative 1, and then solve it.
Okay.
X equals negative 1.
X equals -1. All right. Now let's make these just a tiny bit more difficult. Let's say it's 1/4 equals 2 to the x plus 2 power. Okay. So your goal here now is to get this 1/4 into 2 to some exponent.
It wouldn't be 4 to some. Oh, okay. Yeah. So I remember we just did this. So 4 is 2 squared.
Good.
Uh, would it be 2 to the negative 2 over 1?
Yeah, or just -2. Just the -2.
Okay. So -4 equals x.
Very good. All right, so now let's just, increase the difficulty just a tiny bit more. Let's say it's 1/4 to the power of x plus 1 equals 2 the 5x minus 3. Okay, so this time you're going to replace 1/4, just like you did in the previous problem, with 2 to the -2, but then you have to remember what to do with this exponent.
Can you just multiply both of them?
You just multiply the exponent by whatever the exponent is here, which is -2. Yeah.
Uh, so would it basically just be 4 times x plus 1?
2 to the -2 is 1/4. Is that is that
Oh,
okay
okay.
from the previous problem?
Yeah.
That's
Okay.
plus 1 power.
I got you. All right.
When you have an exponent to an exponent, you multiply those. And because the bases are the same, you can set those equal.
Oh, okay.
We're
Hmm.
going to do more problems like this, but give this one a try and then we'll
Okay.
we'll keep hashing out a few.
X equals 1/7.
Let me look here. That is correct. All right, good. Okay, so let me give you another one here to try. 1/9 to the 2x power equals 3 to the x minus 4 power.
Okay. Okay, so so would it be just -9 times 2x? Oh wait,
No,
no, you have to.
no. You have to convert 1/9 into, we'd really like it to be 3 to some power would be ideal.
So oh yeah, so 3 to the -2, right? And then -2.
Yes.
Yeah.
Keep going.
All right. Okay. Um. Negative 4x. Okay, I got 4 over 5.
That is correct. Good. Okay. So is it clear what we're trying to do here on the 1/9 side or the fraction side? You try to make it into this.
Yeah.
Okay. Let's try another one here. Okay. Let me make one more adjustment here. All right, let's do that. Okay. So same idea as the last, please.
Okay. Okay, I got 2.
That is correct. Okay. So I feel like you're definitely getting this down. You have any questions before we kind of just increase the difficulty, the final kind of difficulty step?
Yeah, let's increase it.
All right. So this is the last type of problem that you'll see. So an example would be like 8 to the 5x plus 1 equals 1/2 to the, actually, let me not do that one yet. Let's do 32 to the 3x plus 7 power. Okay. So what you cannot do is you actually cannot go to 8 to some power. 8 to the 1 is 8. 8 squared is 64. You can see we're way past 32. Okay, so like strategy number one was to go from the larger to the smaller. Strategy number two was to go to the fraction to the whole number. Strategy number three is to change both. So what you have to think about here is, and that's where that exponent table that I sent you a link to can help, is what's another way to write 32 as a base to some exponent? Could you look at that table and see if 32 is anywhere in that gridded area?
Yeah. Well, I see 2n and 5.
Yeah, so that's 2 to the 5th. So 32, let me actually reframe the question here. So this is really 2 to the 5th. And actually, I messed this up. So I'm going to change this to a 4 because it won't work the way I had it written. All right, how about 8? Can you make 8 now into 2 to some exponent?
Yeah, 2 to the third.
So in this strategy, you have to change both exponents. So could you try solving this now? You're going to have to multiply the exponents, move stuff around like you've been doing.
Okay, so would it be -3 and -5 then?
No, 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 they're not fractions. They're whole numbers.
All
You
right,
only
okay.
that only applies to fractions.
So then all we have to do is multiply the
Yeah,
uh, 3 and the
yes.
5 by the. Okay. Okay, I got negative 32 over 5.
5 is right. Yeah, that's correct. Good. Okay, so here's another problem like that. 27 to the, I don't know, let's go x minus 2 power equals 9 to the 4x plus 3 power. So it's just like the previous problem. There's no way to go to 27, 9 to some power. So you have to change them both into a smaller base, which, I'll just tell you is 3.
Okay.
So see if you can work that out from here, please.
Okay. Uh, I got x equals negative 12 over 5.
Let me solve one of these here. I haven't done that in a while, so just to make sure I'm kind of looking at the numbers there. Okay, so this is 3x minus 6 equals 8x plus 6. Should get 5x equals negative 12, and like you said, x equals negative 12 over 5. Okay, so a couple other variations that you might see, some easier than others to determine. Um, this one requires you to be told something to be able to do it. It kind of looks like the ones that we were doing, but this is actually like an exception. So you can turn 1 or into 4 to the 0 power. Okay, that's the only way it is. This is an exception. Normally you would say, oh, well, let's change them, change 4 into 2, but you can't. And you can't change a 4 into a 1. So that's an exception here. So you would set 2x plus 3 equal to 0, solve for x and get minus 3 halves, like that. That's one type of exception that you will
Okay.
see. Any questions on that?
No, I think I get that.
Okay. Now, the other way that they make these more complicated, besides this whole like base thing, and we'll do one of these, like they might give you like 1 over 125 equals, sorry, to the like minus x plus 2 equals 25 to the 3x minus 4 power. So the way that they're gonna try to be distracting here is one fraction, one whole number, but you can't go from 1 over 125 to 25. It kind of looks like you can, but 25 is really 5 to the power 3, and 1 over 5 to the power 3 is 5 to the minus 3 to the minus x plus 2 power. Is that clear?
Okay.
How I got that?
Yeah.
And then 25 is 5 squared, 3x minus 4 power. I did this again. I can't believe I did that. No, I guess that does work. Okay. So then you multiply the exponent by the exponent like that. And I'd like you to take over from here and try solving this.
Okay. Okay, I got x equals 2/3.
Okay. Let's see here. 3 times 2, there's a 2, 0. Huh. Is that what it is? So we got 3x equals 2. Yeah. Okay, good. Um, all right, so the next style of problems here, which we don't have enough time to really start getting into, but I'll just remind you of a few rules here. If they have the same base, you add the exponents, which is a little bit different than what we've been doing. Like, yeah, an example here would be like 2 to the third times 2 to the fourth equals 2 to the 3 plus 4. You add the exponents.
Yeah. Okay.
So if we look at just this here, can you tell me what this becomes when you add the exponents?
2.
What about the m? Does it just disappear?
Oh, 2m.
2m. So this is 6 to the 2m. Now the original problem was equal to 6 to the m minus 4 power. So now you could set the exponents equal and solve. So m would equal -4. So here's another problem you might see. 2 to the y times 2 to the 3y plus 1 equals 2 to the 5 power. So on the left here, give me the new exponent. When the bases are the same, you add the exponents.
Um, it would be 4y plus 1.
Okay, and then you can set the exponents equal and solve that for y fourth, please.
Um, 1.
Got it. All right, we're going to stop there for today. Hopefully